the information that I'm giving you, I'm trying to validate in a broader context than most information comes in. It's usually just laboratory, isolated, abstract information about how a cell works, or this does this to rats, or it's very ungrounded. And so I'm attempting to validate everything that I'm saying through examples of where we find these things in nature, or how we have come across them in nature as an evolving creature. And the next part that I want to tell you about is to flesh out this concept that every food contains poisons and every food contains nutrients. And the simple way of understanding that is that plants don't want to be eaten. Plants produce leaves to photosynthesize for them. They don't produce leaves for us to eat, nor flowers, nor roots, nor rhizomes, nor bark, nor all the other parts of the plants that we eat. They are actually quite well protected. The plant protects itself. And it does so in many different ways. It can make leaves spiky, they can grow in inaccessible places. The main thing that it does is it covers them in very powerful chemistry. And it is chemistry that is deliberately created by the plant to be problematic, so that it encourages you to go somewhere else and eat something else. It doesn't want a particular beetle to start eating its leaves, and so it produces things in the leaves that the beetles don't like. And the same with, it doesn't want apes eating its leaves or its roots or anything else, and so it protects itself. Therefore, every plant has protective mechanisms on it. If we, as an evolving creature, have had to continue eating this plant, then we have had to have created antigens to those poisons, so that we can, in eating that plant, receive those poisons and turn them off in the bowel, hopefully, neutralise them, so that they don't then poison us. But that process of creating an antigen to a new compound that you're finding in a plant or in a food source can take hundreds of thousands of years to develop, because it requires a new gene to be created, and then to express that gene into a cell, and that cell to use that gene to produce a protein or an enzyme that will neutralise that material. So it's a very, very lengthy process. It doesn't happen overnight. It's about hundreds of thousands of years. And then when we've completed that, we can start eating that plant again en masse. And so then the plant has to come up with another defensive mechanism that we then have to neutralise. Each of these processes takes huge spans of time. So over the course of evolution, you've got this huge arms race going on, where they produce a poison, we produce an antigen. They produce a poison, we produce an antigen. And it happens throughout the plant kingdom, on every aspect of the plant, with mostly the sole exception of fruit, because fruit is designed to be eaten. Our lineage co-evolved eating fruit, and the plant's taking advantage of us eating fruit by us dispersing its seeds. There's been massive co-evolutions that have gone on between us in this hugely symbiotic space. So aside from fruit, that's going on all the time. And that works. We have, a rabbit has all the antigens it needs to eat all of the plants that it's likely to find in your average rabbit fodder. But if you suddenly put that rabbit in a completely different place and get it to eat completely different things, it will take a very, very long time before it has the ability to generate all the antigens necessary to turn off all these new poisons in this completely different food source that it's found. And this is where we are. We, in the past 10,000 years, probably more like 1,000 years, have started eating completely different foods. We are arboreal primates, tropical tree dwellers for 120 million years. And then suddenly, in the blink of an eye, in terms of evolutionary timescales, we're eating completely different things. And this is where the major part of our diet falls over. And the second biggest killer of lactobacteria is coffee. And I only really cite that not to piss off all the coffee drinkers in the room, but because it's a very good example of this phenomenon. It's a much bigger phenomenon. And that is that coffee seeds are very, very poisonous. They're some of the most protected seeds on the planet. There's over 2,000 different pathogenic compounds on coffee seeds, of which lectins are one. It was mentioned yesterday. read up, and they are one of a very good example of exactly the kind of things that I'm talking about. But there's many different kinds of them, because plants have had millions of years to come up with these things. And coffee has covered itself in poisons that it has targeted into the endocrine system. So it's created a poison that deliberately messes with the metabolic system of mammals, because it doesn't want mammals eating its seeds. It's deliberately come up with a reason to go elsewhere and eat a mango. I don't want you eating my babies. And the system works. And we haven't been eating coffee seeds for long enough to have generated an antigen for it. And we know that because it comes straight into the system. Caffeine and its 7 different analogues that are in coffee come rushing straight into the system. They come out of the digestive system straight into the bloodstream. And your body goes into crisis management in order to deal with it. It's highly poisonous material. And the way that your body manages poisons at that level is it cranks up the whole endocrine system. It speeds up the blood pressure, increases the blood pressure, speeds up the heart rate, with the sole purpose of getting the blood through the liver as fast as possible so that the liver can clean out the blood of this stuff. And then the blood can start to calm down. But then the liver goes into convulsions to get rid of this stuff, because it's such a toxic material it irritates the liver. So the liver goes into convulsions and sends it into the bowel, and then the bowel goes into convulsions to get rid of it, and it comes out. But the experiential end of that, the front end of that, the reason why we drink coffee, is because when you speed up the endocrine system like that, you get a lift, you get a wake up, because your whole system is made to be alive in order to keep you alive. You get a lift out of it, and that's the hit you get out of coffee. And then you get liver contractions going on, and that's the holistic use of coffee. That's things like coffee enemas and liver flushes and that kind of material. It purges the liver. In other words, it squeezes the liver so hard it happens to knock out a bit of the crap that's congesting the liver as well. So the liver is left more free-flowing after that. And then it goes down the bile duct into the intestines, and the intestines go, "Ugh, I don't want it either." And that's the deconstipating effects of coffee, which is fantastic. We've solved 3 problems by drinking 1 drink. There's not many things you can say that about. We've woken ourselves up, we've decongested the liver, and we've deconstipated the bowel. And no one is therefore asking, what are we doing in our lives that makes us so sluggish that we have to use a really heavyweight plant chemical to wake us up several times a day? And why is that, what are we doing that is so congestive to our livers that we need to sweep it clean with the plant poison? And then what are we doing that is so constipating to the bowel that we need to use this acrid chemistry to open the bowel? We don't need to ask any of those questions because we've got the symptom management in a cup. But it's an interesting set of questions. What is it that we're doing? And the thing that I would cite most strongly as what we're doing is using the same things as coffee is an example of, and that is grains. Grains are cited as, hailed as being one of the great wonderful discoveries of the human race that have allowed us to live in all kinds of stupid places like this where nothing grows for months of the year and you can store grains to survive that process. Great, it's a staple, and that's true. In terms of civilization spreading out across the world and empire building and all the rest of it, grains have really worked for us. But biologically they are a nightmare because they are a grass seed. That's what grains are. Phytologically they're classified as grass seeds. And we are arboreal primates. We have no business eating grass seeds. We have no way of defending ourselves against the deliberate problematic materials that coat grass seeds. And this gives us problems because we don't have the antigens to their poisons. And they have the best poisons available. Grass seeds are prolific across the whole planet. And notably, there's not one animal, except one, that has learned to specialise on grass seeds. Which is very interesting. Grass seeds are an entire plant in a very dense, calorie-rich, nutrient-dense package. They're a fantastic food for any animal who can learn to deal with them. Not one has. This should say something. And it does say something. What it says is they are protected so well that any animal that tries to eat them will be killed off. And the way that that works is through a type of chemistry that most people are starting to hear about called phytoestrogens. And phytoestrogens are now being hailed as the way of propping up the failing estrous cycle in menopausal women. We're starting to hear about these things as their uses. But the plant isn't producing them for that purpose. The plant is producing them because they are endocrine disruptors. They're hormone mimics. In other words, if you look at it in a molecular sense, it looks like estrogen at one end. And when you eat it, it plugs into the estrogen receptors in cells and gives off very strong estrogen messages. So it messes with the hormone balance of any mammal that will eat it. And so perhaps there have been thousands of different mammals over the course of time that have tried to specialise on this highly dense, calorie-rich food source. But they end up eating so much of it, they take in so much phytoestrogen that their hormone balance shifts and they die out. And so they're not around anymore. The only animal that has been able to do this with any degree of success is a bird. Is birds. Because birds have, as a part of their anatomy, they have evolved, as a part of their anatomy, an entire organ solely to deal with this problem. Because they've had to consume grass seeds to get their nutrient flow. And so they have evolved a system of dealing with it. It's called a crop. It sits just above the stomach. And the seeds that it eats fall into this crop where they stay in a nice warm, moist environment for 24 hours or so. And in the nice warm, moist environment, these phytoestrogens and the enzyme inhibitors and all the other many of the other protective elements on the seeds get washed away. They're water soluble. They're extensions of these enzyme inhibitors I was talking about yesterday that coat a seed, that give it a timing mechanism. And so all of those protective elements are washed away, and the seed then comes back out of the crop and falls into the stomach as undefended nutrition. And that's how birds can eat grass seeds. Because they've evolved having to, and they've evolved a mechanism to deal with this problem. We are arboreal primates. We live in the treetops. We don't eat grass seeds. We don't have a crop. We would suffer the same fate as all the other animals that have attempted to try to eat grass seeds. And this is what we see. We, as a nation, as a civilization, should be bouncing off the walls with the amount of energy we are taking in from these high carbohydrate foods that we're eating. The amount of grain that goes into your average human being. We should be running marathons, but we're not. We're heavy, we're sluggish, we have to have things that wake us up, we have to have things that keep us awake, we have to get off of sofa with effort, we have to get out of bed with effort and reach for caffeine as soon as we can. Because all of these grains that we're consuming clearly aren't giving us the energy that they are designed to. Because actually they're designed to not give us energy. They're designed to give the energy to the sprouting process. And we don't have a means of digesting them properly. And we know that we don't have a means of digesting properly because they taste bland. Nobody eats a bowl of grains. Our entire culinary explosion, all of our culinary genius is based upon, it's going to have a large amount of grains in it, so how do we make that taste nice? We invent bolognese sauce and slap a bit of butter on it and a bit of salt or a bit of cream and a bit of sugar and boom, you can't sell the things fast enough. But nobody eats just a bowl of grains because your taste buds are telling you there's nothing in there I can use. Do you get that? Get that difference? Nobody eats a bowl of pasta. Occasionally someone says, well I do, with a little bit of olive oil on it and a sprinkle of salt or chopped up garlic into it, something that actually makes it palatable. But in essence, these are really bland, boring, dull, nutritionless, gluey foods. They do things for us, but it's got nothing to do with nutrition. It's about filling us up, gluing us up would be another way of saying that. It's about cheapness, and was about survival in areas where food doesn't grow for a very long time. In other words, overwintering. It served us massively in our need to end up populating areas of the planet that arboreal primates weren't designed to be in. It has served us. But in terms of nutrition, offers us nothing. It fills us up. We are arboreal primates. We do what all arboreal primates do and actually what all mammals do. We eat constantly. The need to fill us up is an economic need. It means that we can then not eat for 4 or 5 hours at a time, which means that we can go out to work without having to think about food. That's got nothing to do with nutrition. That's economics. And it's, I don't mean to shake a stick at any of these things and make them wrong, but it's useful to note that you're not doing that for any nutritional purposes. We eat grains in order to create space in which we don't need to eat. But the instinct keeps shining through, well, I'll just snack on that and I'll just have that, I'll just have one of those, I'll just have 3 of those. Because we love to eat all the time, and that is an instinct. That's not weak will, that's an instinct. So make friends with that. Don't eat such dense, heavy, gluey, intensely indigestible meals. Eat lighter meals that are less indigestible and eat more of them. Fantastic. Perfect solution. I'm a pig. I love eating all day long. The idea of only being able to eat 3 times a day, why would I want to do that? I love eating. But we've got this whole association around snacking makes me fat, snacking makes me, it will give me diabetes, la 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 la. It's rubbish. It's about what we're eating. Get back into your sort of monkeyness. We love eating. Allow yourself to eat. So the whole idea that we like grains, that grains are this mainstay of our diet that we enjoy, that's true, as long as you can cover them in all kinds of things that make them palatable. You take that to bits, and you start to see some very different things about it. You can't sell half a kilo of refined white sugar to anybody, refined white flour to anybody to eat. But you mix it up with a kilo of sugar and a couple of dollops of cream and sell it as cakes. Out they go. People love them. But that's not because people are attracted to the flour. That's because people are attracted to the sugars and to the fats and to the salts. And this is where we come into actual nutrition. This is what your taste buds and your digestive system are designed to hunt for.